This week we're going to be doing our Unit 1 assessment. So Unit 1 was all about digital information, so we talked about the idea of binary, right? Zeros and ones. You should understand at this point that everything a computer does comes down to zeros and ones. So we talked about how to convert binary to decimal, decimal to binary. We talked about this idea of a bit, which is, a 0 or a 1. It's that smallest unit of measurement. If we put 8 bits together, we have 1 byte. From there, we talked about, abstraction. Everything that a computer does can basically be considered abstraction, right? Because everything behind the scenes is zeros and ones. We remove that complexity by writing software applications and programs to do things simply. So the average user doesn't need to know about the zeros and ones behind the scenes. They just interact with the application. You do need to understand that there are these layers of abstraction. Right, so if I'm like sending a text message, right, at that top layer, that's the abstracted layer, you just type the text and hit send. You should now understand that behind the scenes there's an encoding schema that's using ASCII, that's converting each one of those characters to a decimal number. And then beneath that, we convert that decimal number to binary sequence. That is what is being sent back and forth. So when the other computer receives it, it's receiving zeros and ones. It brings it up to that ASCII level, and then the program will display that text to you, right? So we're removing that complexity from the end user, but we need to understand how that works. That got us into the idea of analog versus digital. We live in this analog world. Everything is like nice, smooth, continuous, whether it's the light coming into our eyes, or the sounds coming into our ears. But for us to store this information in a computer, we need to convert those smooth, continuous analog signals to these digital signals, which are discrete and have finite points in time, that we have sampled that data to grab a value and convert that value down to binary that can be stored and sent back and forth. So obviously, the more frequently that we sample this analog data to convert it to digital data, the more the more similar, the more, not even sure how to say it. The higher the sampling rate, the more it's going to look and sound like the original analog signal that we experienced. But there's a trade-off in that when we sample at a higher rate, we're going to increase the size of the data, and we need to account for that. So sometimes we're okay with a little bit of a trade-off where we might lose some quality if it means that we can store it and send it easier. We also talked about, color images and this idea of RGB, which got into, bits per pixel and stuff like that. So with RGB, we have 8 bits to create red, 8 bits to create green, and 8 bits to create blue. And then this combination of zeros and ones for each one of those 8 bits, for each one of those 3 colors. This creates the color of the pixel that we're going to see, right? And then we combine all of these pixels into the image that we're looking at. So when we're zoomed out looking at it on our screen, it looks like a nice clear image. But if you were to zoom in, you would see that it's made up of individual pixels. Each one of those pixels has an individual color. And that's where our gradients and stuff like that come in. So the idea of 8 bits per pixel, that's what we're using these days. That creates all of that color depth that we see. We then talked about compression, right? So now that we have this file with these zeros and ones, I want to try to make the file a little bit smaller so I can send it to someone else, or when I store it, I'm taking up a little less room. So we had 2 types of compression. There was lossless compression. That is when no information is lost. We can completely reverse it. And the idea was we were going to have the compressed message along with this dictionary, which is like a key that tells the sending and the receiving computer how to convert that compressed message back to its original form. And then we also had the lossy compression. This is when we do lose data, right? We're just okay with it. So if I'm going to send a text message to someone that has text, I probably want to use lossless compression, because when they receive it, I don't want any data lost, right? Lost data means that there's characters not displaying on their screen. The message probably isn't going to make sense. If that text message is an image, I am okay with some data loss, because if I have this nice clear image, but someone's going to be looking at it on their tiny little phone screen, when that little picture is shown, even if it's compressed and I've lost some data, I've reduced the number of pixels, I've reduced the resolution, on my little phone, it's still going to look pretty good, right? So there's this idea of when do I use lossless, when do I use lossy, and that trade-off in regards to the resources that the computer needs to store and send that data. And then we also talked about intellectual property, right? So copyright, Creative Commons, who owns the data, what can you do with the data? So we kind of need to bring all that together into this Unit 1 assessment. So just like last semester, there's still going to be, 2 things for you to do assessment week. There's going to be a project and there's going to be a multiple choice exam. So the multiple choice exam, you can just open that up, take it when you're ready. You get 1 chance to do it. Your score is your final score. For the project, we're going to go into that one a little bit just so you can kind of see. This project focuses on the intellectual property part of this, right? It's easy for me to test you on the binary, compression, images, RGB, abstraction with the multiple choice. What I want to make sure you understand is this IP part of it as well. So when you open up the project, you're going to see it's kind of a long explanation. Definitely read through all this because it explains everything you need to do and it gives you a lot of useful articles and things that you can look at to make sure you're on the right track. I'm going to kind of quickly go through these. So up top, this is your project instructions. I'm going to go through this in the video. These 3 are sample projects that you should look at to make sure that you're doing your project correctly. I'll go through these and kind of explain these when we get there. Basically, what you are going to be doing starts right here. So there are 3 articles for you to read. All of these have to do with AI, digital information and what we're doing with it and the issues that it's creating. So what I want you to do is read these 3 articles. One of them is about computer-generated actors in movies. One of them is about DNA testing kits and this whole idea of digitized DNA. Who has that information? What is it being used for? What does that mean for us as a society long term? The third one is about the game NBA 2K and a lawsuit that came about because the tattoos that were being displayed in the characters in the game, right? These NBA players, technology got to the point where they could actually recreate the tattoos that were physically on the player in this digital game. And some of the tattoo artists started suing the creators of NBA 2K saying like, hey, that is my work and you shouldn't be using it without paying me, right? And then even some of the players in the NBA that were named in this lawsuit kind of started getting involved saying like, it's actually my tattoo and I should be getting some money, or I don't care if that's used because that's part of my identity and who I am. So you can read these 3 articles. What you're going to do is choose one, right? Your entire project will be done on one of these 3 articles. I'm going to explain access in a minute, but what I want you to do for the project, you are going to start by marking up your article. So whichever article you choose, you're going to make a copy of it. This copy will be turned in to me. So as you read it through the first time, you have to, in Google Docs, in your copy, highlight or underline any information about that article that you want to know more about, right? I am just going to look to make sure that you have highlights or underlines in there. At the end of the article is a little box where you need to write a 10-word summary about that article. Okay, so first thing you need to do is read the 3 articles, choose one of the articles. Once you've chosen an article, make a copy of it, read it through again, highlight, underline anything else that you want to learn more about. At the end of the article, write your 10-word summary. Once you do that, you're going to reread the article again, and you need to annotate the article. All right, so as you go through and annotate, what I'm looking for is any sentence that shows a benefit. So if you think this technology, maybe you're choosing the AI-generated actors, if it is a sentence in the article that supports the idea of generated actors as a benefit to society, you're going to put a plus next to it. If you think it shows harm, you're going to put a minus sign next to it. If you think it shows impact, you're going to put a face next to it. And then you can add some comments into your article that show me that you've thought about this and looked at it. Right? So I'm going to be looking at your article for the highlights, the underlines, the 10-word summary, and these annotations. I need to see a couple pluses, a couple minuses, a couple of the little face symbols, and then some comments in there. All right? Once you have that, you need to create what we call a position poster. So you can do this, physically on a piece of paper. You can open up a Google slide. You can go into Cami. I don't care how you do it. I would say of all the options, physically doing it on paper is probably the worst one. All right. The idea is you're going to break that up into 4 quadrants, right? So the upper left is quadrant 1, upper right, quadrant 2, 3, and then 4. Each one of these quadrants, you're going to answer a question. All right. So kind of looking at this first box, what you need to explain to me is what is being digitized and how is this information being represented digitally. All right, so you need to tell me it's actors that are being digitized. This is how it works, right? This is how they're doing it. In box 2, what is the goal or the purpose of digitizing this information? Why are people doing this? In the third box, you're going to talk about the benefits and the harms, right? So explain, how does this benefit some people and how does this harm some people? And then in the fourth one, you need to take a position and kind of tell me, do you think the world is better or worse because of this digital representation? Right? So do you think we are better off or worse off because of this? And you need to explain this by using examples in your article. And this is a couple examples really quick. This is an article. This is the tattoo one. You can kind of see that they've added some minuses. They've added, some pluses in here. They've added some faces, and they've added some comments. Right? So when I'm looking for the annotations, this is what I'm looking for. Did you add comments? Did you add faces? Did you add pluses? Did you add minuses? The only thing this is missing, is like things that you want to know more about. So you would highlight a sentence, here or there, just to kind of I can see that you read this, right? That's what your article should look like. This is a sample poster that would get a pretty high score. They have their 4 quadrants, right? They just did this in Google Slides, and you can see each quadrant has like a paragraph. I'm going to be more specific on the paragraph in a minute, but you need to write a paragraph, right? So answer, what is being digitized? Why? What are the benefits and the harms? Don't do benefits or harms. It's benefits and harms. And then take a position. Are we better or worse for this? So this would be a pretty good project. What this is missing, which you will see in the project, as you're reading through the rest of this, right, it's just explaining to you what I'm saying right now. You need to add a background and you need to add some images to your digital position poster, right? This one would not get full credit because there's no images, there's no background. It's too plain. I want something that looks nice. So make sure you add a background and you add some images to it, right? It's this point right here. You need to explain your information. You need to do it, again, I would do it digitally because I think that makes it a lot easier in regards to adding the background and adding the images. This is an example of something that would not get much credit. Right? This one sentence answer, that is not good enough. Right? This is just your rubric. I'll let you guys read this over. Each one of these categories is what I am going to be grading this on. So as far as APCSS goes, right? This is an acronym, but what you need to understand is, and this really comes into play this semester, you're going to be required to write several paragraphs to do this project, right? You're going to have to do probably 5 at a minimum. if you give me 2 or 3 sentences, you're not going to pass. All right, this is a college level course. We are articulated with MSJC. You're going to take an AP exam at the end. I expect college level answers, which means I want full paragraphs from you. So most of you know how to write a paragraph. Axis is just the format that I give students to help them write their paragraph. So I am looking for you to write this using this axis anagram or analogy. So the A is your assertion. This is your first sentence. You need to tell me what you're trying to prove. What is your main point? What is your claim? Right? Everything else in your paragraph is going to support this sentence, but you need to be specific and you need to answer the question directly. The next sentence or two should be examples. So I should be seeing examples from your article that you are going to use as evidence or proof towards your assertion. This part in green, the explain, that is what comes after your example. This is the largest part of your sentence. It's going to be 2 or 3 sentences, or sorry, largest part of your paragraph. It's going to be 2 or 3 sentences. You need to explain how and why your example proves your assertion. Don't assume that the reader or I understand the connection. All right, you need to explicitly state it. How do your examples help prove your assertion or your claim? And then at the end, you just need to give me a sentence, maybe 2, tying it together, right? This is your conclusion. Why does this matter? Explain why your assertion is important and how it connects to the bigger picture of what that question is asking. This is just kind of an example. You'll actually see this next week when we start getting into the FRQ practice. But this would be a paragraph that I'm looking for, right? The question posed to the student was to describe the overall purpose of their program. So this is regarding their code, and explain one way a specific feature of the program's design helps achieve the purpose. So this in blue, this is their assertion, right? The purpose of this program is to help students practice multiplication and division problems in an interactive way, and the program's design supports this purpose by allowing users to choose which operation they want to practice. That is my assertion, that is my claim. And then I give the example. For example, when the program starts, it prompts the user to select either multiplication or division before generating practice problems based on that choice. So that is my example that I'm going to use to prove my assertion. This part in green, this is where I explain it, right? I'm going to directly tie this together in a way that the reader understands it, right? I'm not going to assume that they get it. This design choice helps achieve the program's purpose because it allows the program to adapt to the user's learning needs instead of forcing the user to practice both operations at the same time. By letting students focus on one type of problem, the program keeps practice targeted and reduces frustration, which helps users stay engaged and learn more effectively. That is my explain. So now I need to do the significance. I need to conclude this and tie it together. This design helps the program successfully achieve its purpose by supporting the user's learning needs. All right? I'm looking for paragraphs like this when you fill in your quadrants, right? The reason I say probably 5 paragraphs, not 4, even though there's 4 quadrants, this one is asking for benefits and harms, right? So you need to address the benefits and you need to address the harms. If you want full credit, you need to give me a paragraph for benefits using Axis and a paragraph for harms using Axis, right? Your text is going to be small. I get it. It's not a lot of room, but you need to do it. So that is pretty much it, right? If you read through this, it's basically what I just said in this video. So I suggest you read through it. You can watch this video again if you need to. You have this slide presentation that kind of walks you through what each quadrant needs, along with the explanation in Canvas. You have the example of what your article should look like with the highlighting or the underlining in your annotations and comments. You have a sample of what a pretty good one looks like. You have a sample of what a not good one looks like. All right, and then you got your rubric. So if you have any questions about this, come see me. Otherwise, good luck, and we will talk next week.